Okay, so let's go over some exponent examples. Okay, using the rules of exponents that we outlined in the previous video. Okay, so looking at some examples, let's assume we have x to the fourth divided by the cube root of x. Okay, so using our rules of exponents, the easiest thing to do with this is to go ahead and convert that denominator using the rules of exponents into something that is easier to read, easier to look at. Okay, I know that's not a very sophisticated term, but lack of a better term, let's turn that denominator into something easier to look at. X to the fourth is easy to look at. X to the the cube root of x is not very easy to look at. So if we go back to our rules of exponents, we know we can rewrite this fraction as x to the fourth divided by x to the 1/3. Okay, using our rules of exponents again, we get x to the fourth minus 1/3. Okay, using our rules of exponents again, we get x to the, what is that, 3 2/3, and putting it full in full fractional form, that's the same thing as saying x to the 11/3. Okay, so this here equals x to the 11/3. What about, let's say, the fourth root of x squared divided by x to the fifth? What about that? Well, again, the easiest thing to, x to the fifth is easy to look at, right? Using the rules of exponents, that would simply be x to the -5, right? That's a little bit harder to look at. So let's make that numerator easier to look at. Now, going to our rules of exponents, we know we can rewrite this as what? X to the 2/4. Okay? Remember, the root goes in the denominator of the fractional exponent, divided by x to the fifth. Okay? Now, we can simplify that by reducing it some. That's the same thing as saying x to the 1/2 divided by x to the fifth. Okay? So now, using our rules of exponents, we can put that in this form here. So that equals x to the 1/2 minus 5. Okay, now what is 1/2 minus 5? It's -4.5, so that equals x to the -4.5. Okay, and we put this in fractional form, we get x to the -9/2. Okay, now we can rewrite this one more time by getting rid of the negative exponent, and maybe and many times we want to do that, right? Simply because positive numbers are easier to look at. How can we use the rules of exponents to rewrite this? Well, this equals x, okay, to the 9/2, but that's in the numerator now, right? Because that is a negative fraction. So this can be rewritten like that. And many times this is a far easier way of looking at that result than that is. Let's do something real complicated. What about x to the third to the second power? What is that? Well, that's actually easy. It's not complicated at all, right? Because using our rules of exponents, that equals x to the 3 times 2, which equals x to the 6. And that's easy. That's easy. What about something quite complicated, such as the cube root of x squared times x to the 3 halves times y to the 4th divided by y cubed. Now that's a hard one. And you know, stop the video right here and try and work this out. And then come back to this because I'm getting ready to work it out right now. So again, the first thing we want to do is rewrite this to make it a little bit more pleasing to the eye, and you know, no, get rid of that radical sign there. Okay, what is this? Well, that is x to the 3 over 3. Okay, times x to the 3 halves times y to the 4th divided by y cubed. Okay, now here's the interesting thing. If we've got two x's, and we're going to see this when we get to polynomials, if we got these two x's, of course, and using the rules of exponents, we can combine that. So that equals x to the 3 over 3 plus 3 halves, okay, times y to the 4th divided by y cubed. Okay, so we've got 3/3 plus 3 halves. Let's simplify this, taking it step by step. Let's not worry about the y's yet. Let's just carry the y's through the operation for now. So simplifying these exponents, we get what? X to the 1 plus 3 halves times y to the 4th divided by y cubed. Okay, now 3 halves is 1 1/2. What's 1 1/2 plus 1? That's x to the 2 1/2. Okay, so that's 1/2 plus 1. 3 halves plus 2 over 2 in order, you know, get your common denominator. That equals 5 over 2. Okay, and that's 2 1/2 times y to the 4th divided by y cubed. Now, using the rules of exponents again, we know that y to the 4th divided by y cubed is equal to y to the 4 minus 3. So this all then equals x to the 2 1/2 times y, 4 minus 3, times y to the 1. Okay, turning this into a fractional exponent makes it a little bit easier to read instead of 2 1/2. Then we've got x to the 5 halves y. So all this mess here we simplified by using the rules of exponents to just that. Okay, all these operations are called simplifying. Okay, we're going to do a lot of simplifying in this class. In other words, taking something that's complicated and condensing it down into a much simpler form. But these are some examples of